we're going to take a look at three more examples of systems of equations applications in two variables. So we have our pharmacist. They need to prepare 12 ounces of a 9% solution. And unfortunately, they don't have the 9% solution available. They have a 4% and 12% solution available. We want to try to figure out how much of each we need to mix to get 12 ounces of 9%. All right, so let's define X, and X is going to be the number of ounces of our 4% solution. And let's define Y to be the number of ounces of the 12% solution. Our system, if we set it up, we know that the total number of ounces should be 12. All right, so one equation is going to be that if I add the number of ounces of the 4% and the number of ounces of the 12% of the 9%, then we should end up with 12 ounces. For the other equation, we're going to have 4% of X. Okay, so we have a 4% solution that's X. Okay, so 0.04, remember, is 4%. 12% of Y, so 0.12Y. And that's going to be equal to our 9% of 12 ounces, so 0.09 of 12. All right, so this is just basically verifying the composition. Okay, so 4% of the number of ounces of X, 12% of the number of ounces of Y. When we mix those together, we should get 9% of 12 ounces. Right? Now we know that 9 times 12 is 108. Okay, so we can just change this right away, and we can make this 1.08. Right? Now we can solve the system by any method we choose. Let's choose elimination. Okay, so what I'm going to do first is I'm going to multiply this first equation, or the second equation, by 100, just because I want to eliminate all the decimals. Okay, I don't like decimals, I don't like fractions, I don't want to deal with them. So we get x plus y is 12. When I multiply by 100, I get 4x plus 12y equals 108. Now I'm going to cross multiply. I'm going to multiply the second equation by 1. I'm going to multiply the first equation by -4. All right. And the reason I do that is because I want to make sure one of the coefficients is opposite. One of them is going to be or negative. One of them is positive. New system, -4x minus 4y equals -48. Okay, so we just multiply everything through by -4. And then the second equation remains unchanged because when we multiply through by 1, we get the exact same thing. And that's going to be 108. Okay, so now if we solve, these cancel out. -4 and 12 is 8y. 48 and 108, that should be 60. All right, but just to make sure, we have 108 minus 48, and that's indeed 60. And I know this isn't the nicest number in the world, but when we divide 60 by 8, it should be 7.5. So let's just verify that. So 60 divided by 8 is 7.5. Okay, so y is going to be 7.5. And then we could just substitute back in to where x plus y is 12. So we get x plus 7.5 is 12. If we subtract 7.5 from both sides, we should end up with 4.5. All right, and so what is the answer to this? Well, we need 4.5 ounces of the 4% solution, and we need 7.5 ounces of the 12% solution. Okay, because remember, we need to actually answer the question. The question was find out how much of each solution we need. Okay, so this one was a pretty tough one. Okay, but that doesn't mean necessarily it's too difficult for us to be able to work through once we've seen a few examples of this. Second example, a theater sells adult and child tickets for different prices. 3 adult, 4 children are 159. 2 adult, 3 children are 112. Find the price of 1 adult and 1 child ticket. Let's call X, let's call that the cost of an adult ticket. And let's call Y the cost of a child ticket. And so if we go through and solve this, okay, We know that 3 adult and 4 child tickets is 159. Okay, so 3x plus 4y is 159. 2 adult, so that's 2x. 3 child, 3y is 112. Okay, so there's our system right there. Just like we've done plenty of times, we're going to cross multiply. I'm going to multiply the first equation by 2, the second equation by -3, all right? Or -2 and +3, it doesn't matter, okay? Distribute 2 to everything. So that's going to give me 6x plus 8y. 2 times 159, that's going to give me 318. And I'm just going to verify that by using a scientific calculator. So we have 2 times 159, and that is indeed 318, right? Negative 6x minus 9y is going to be equal to negative 336, okay? So I'm going to take 3 times 112, or negative 3 times 112, and that's negative 336, right? If we combine, these cancel. 8 minus 9 is negative 1. And then 318 minus 336 is a negative 18. And so y is equal to 18. Now what we're going to do is we're just going to substitute into either of the equations. I'll just substitute right here. 2x plus 3 times 18 is equal to 112. I know 3 times 18 is 54. I'm going to subtract 54 from both sides. So we have 112 minus 54, which gives us 58. Okay, so that's going to be 2x equals 58. And if we divide by 2, x should be equal to 29. Okay? And so when we answer the question, x is $29. So it's going to be $29 for an adult ticket. And then it's going to be $18 for a child ticket. All right, so hopefully they're seeing something pretty good for that amount of money. All right, finally, one last example. A restaurant is to contain 2-seat tables and 4-seat tables. Fire code limits the restaurant's maximum occupancy to 58 customers, right? So the owners have hired enough servers to handle 17 tables of customers. Find the kind of each table and how many of each table they should purchase. All right, so let's let X be the number of 2-seat tables. And let's let Y be the number of 4-seat tables. All right. Now, the owners have hired enough servers to handle 17 tables total. So one equation is going to be that X plus Y is equal to 17. Another equation is that, well, there's going to be 2 people at each of these tables. So there's going to be 2 people at each, or 2 customers at each of those tables. There's going to be 4 customers at each of these tables, the 4-seat tables, right? And the maximum occupancy is 58 to optimize this, right? So that's our system. If we multiply the first equation by -2 and the second equation by +1, we get negative 2x minus 2y equals negative 34. And then 2x plus 4y equals 58. These are going to cancel. 2y, that should be equal to 24. All right, but I just want to make sure because, again, all day my arithmetic's been off, which isn't good. So we had negative 34 plus 58, which is 24. All right, and so we divide by 2, and y is equal to 12. Right? If we go back up here and substitute, x plus 12 is 17, so x should be equal to 5. Okay, so we have 5 tables with 2 seats, so we would order 5 of the, I was about to write the number 2, but let me write it out, 5 2-seat tables, and we would have 12 of the 4-seat tables. And of course, just to check this, we would have 2 times 5 is 10, and then 4 times 12 is going to be 48. The total would be 58, and that's the maximum number of customers. So at least the answer makes sense to us. Okay. All right. So that's our system of equations in two variables. Okay. So lots of different things that we learned in this section. Remember the three methods for being able to solve. Remember our graphing method. And then also we took a look at our applications. So in our next video, we're going to take a look at how do we solve equations that have three variables and three equations.